Got an interesting problem here today. Simplify 2 times the radical 4x to the third minus 16x squared plus 16x. So right off the bat here, right away, I'm seeing a lot happening inside the radical. But I'm noticing a trinomial. I see a 4x to the third minus 16x squared plus 16x. So that tells me that maybe I can do something with that. Maybe I could create some sort of trinomial that would be a perfect square. Like maybe I could get into some sort of form of like x minus 2 squared or something like that, where I could just factor that, where if I take the square root of x minus 2 squared, I just get x minus 2. Same reason why if I take the square root of 2 squared, which the square root of 2 squared is the square root of 4, that's just 2. When you take the square root of something, like if I take square root of 2 squared, what I'm doing is I'm doing 2 to the 2 divided by 2, this exponent of 2 divided by the radical. So if it's a cube root, it'd be 2 over 3, fourth root 2 over 4. So 2 over 2 is 1, so you just get 2 back. Hopefully I could create some sort of scenario where I can get this to happen. Let's see. Now, first of all, I'm noticing a 4, 16, and a 16. So I can factor out a 4 from there, which is nice because 4 is a perfect square. So let's rewrite this. So 2 radical. I'm going to take out 4. Also, well, I'm actually talking about factoring, x to the third, x to the second, x to the first. I can take out an x from all three of those terms. So I'm going to take out an x. That means I'm dividing each term by the 4x. So I'm dividing everything by 4x here. So 4 over 4, so I'm taking out 4x. So 4 over 4 is 1. X to the third over x to the first is x squared. Minus 16 over 4 is 4. X to the second over x is x. And then 16 over 4 is 4. And that is going to be x. X is canceled. So we're just left with x squared minus 4x plus 4. Cool. This looks like pretty promising. Now, also, before I even look at this trinomial, I'm seeing this square root of 4 here. Square root of 4. Since I have a square root of 4, square root of 4 is just 2. So that 2 can just come out of the radical. If you want to rewrite it right away, you can. And now, since I have a 2 on the outside, though, so technically this is like a 2 square root of 4, because the 2 is on the outside. So when this happens, square root of 4 is 2. There's a 2 on the outside, so we have to do 2 times 2. So now we're going to have 4 radical x, x squared minus 4x plus 4. On the inside of the radical, the x can't do anything with that because it's not x squared or even x to the third. It's just x to the first, so that x is going to stay in there. It's kind of locked. But the x squared minus 4x plus 4, if I look to factor this, look what I have. I need 2 numbers that multiply to 4 and add up to a negative 4. That's negative 2 times negative 2. So I'm going to have 4x times x minus 2 times x minus 2. Well, I could rewrite that as 4 square root of x, x minus 2 squared. Exactly what I said at the beginning of this video of what we want to have happen. We want some sort of scenario where we have that binomial being squared. So x minus 2 squared. Since I have the square root of x minus 2 squared, that's just going to give me x minus 2. Same reason as I said before at the beginning, square root of 2 squared is 2, because that's the square root of 4. So I'm going to have 4 times x minus 2 square root, I probably should put that radical so big, square root of x, because I still have that x on the inside. The square root of x minus 2 squared became x minus 2, so that came out. Same reason when you have the square root of 4 and you get 2, you don't have 2 root 2 for the square root of 4. Square root of 4 is just 2 times 2, so it just becomes 2. The radical goes away because just 2. Square root of 4 is just 2. Same reason here. Square root of x minus 2 squared is just x minus 2. So we have 4 times x minus 2 square root of x. That is a really cool problem. That's definitely a really interesting puzzle to solve there, trying to simplify that down and seeing that we have this GCF of 4x everywhere. So I could take that out, and then I create this really interesting trinomial, which then factors into a scenario that I could take the square root of it. It's really a really fun sequence when you see it play out like that, and being able to see that as you work through it. And sometimes you might not be able to see it. Like, I didn't necessarily know that this was going to happen. I had an instinct that, like, I think when I'm given this type of problem, I think that's probably going to happen. I think I'm going to get some sort of scenario where that's going to happen. It's not always going to happen like that. Sometimes you might factor, and all we get at is that square root of 4 is 2, and then this might be the answer. You know, like, it might be a trinomial that doesn't even factor or something weird like that. But in this case, everything kind of just fell into place, and that's a really interesting problem.